Year 11, January 2022 mock exam. So in this first multiple choice question, circle the number that is closest in value to 29 cubed. We're going to think about the fact that 29 is approximately 30, and if we were to work out 30 cubed, well, 30 multiplied by 30 multiplied by 30 would be equal to 27,000, so the closest value will be 27,000. Question 2, what is 800 million in standard form? Well, that's 800, and then we want 6 extra zeros for the 800 million. So in standard form, we want 8 times 10 to the power of, and if we count, that's 1, 2, 3, 4, 5, 6, 7, 8. Jumps after 8.0, so 8 times 10 to the power of 8, selecting the second answer. Question 3, circle the highest common factor of 6x squared y and 4x cubed y. So highest common factor, the biggest factor that divides into both of these terms. So 2 is going to be the numerical value, which instantly rules out this one and this one. This is to test whether you understand the difference between a factor and a multiple, because the two values on the end, the two terms on the end, the third and fourth answers, they're looking at multiples rather than factors. Now, both of these have factors of x. We have x and x cubed, but we can't go higher than the x, so that means we just have 2x. And then if we look at the y part, we have y squared and y. We can't go higher than the y, so it's 2xy. That's the highest common factor, the biggest factor that divides into both 6x squared y and 4x cubed y. Last question, expand and simplify this expression here. So we have 10x plus 6 minus 8, and then it's minus 9x, so that's plus 9x in the end. So that gives us an answer of 19x minus 2. So question 5, which is all about truncation, not rounding, truncation. So a number has been truncated, so cut off after 2 decimal places, and is now 3.64, which means that the number must have started with 3.64, and there could have been any digit after the 4 there. So that means we instantly rule out this one and this one there, and it's down to the other 2 options. Now, truncation means the number could have been anywhere from 3.460, etc., all the way up to, but not including 3.65, because of course that's truncated down to 3.65, which means we can't have the option here because it's less than or equal to 3.65, and 3.65 would truncate to 3.65, not 3.64, so the answer is this one over here. Question 6, part A, solving a simple linear equation, multiply both sides by 6, so we have 2w minus 3 equals 24, add 3, 2w equals 27, and divide by 2, so w equals 27 over 2, or 13.5 as a decimal. Part B of this question involves factorising a simple quadratic equation. You could use the quadratic formula, but it creates an awful lot of unnecessary work. So this quadratic factorises as x minus 5, x plus 4 equals 0. So of course that tells us that x minus 5 equals 0, which gives us x equals 5. And the other bracket gives us x plus 4 equals 0, or x equals negative 4. So question 7, on a map the distance between 2 towns is 6 centimetres. The actual distance is 1.2 kilometres. Work out the scale on the map as a ratio in its simplest form. So if we compare these two values, the map and then in real life, so 6 centimetres matches up with 1.2 kilometres. So I'm going to convert 1.2 kilometres into centimetres. So that tells me that 6 centimetres. Now, if I want to convert 1.2 kilometres into centimetres, I might start by converting into metres first of all. So we know that 1 kilometre is the same as 1,000 metres. So I'm going to multiply 1.2 kilometres by 1,000 to convert into metres. so that's 1,200 metres. And of course, if I want to convert metres into centimetres, we know that 1 metre is equal to 100 centimetres. So we multiply by 100. So we're in metres, but we want to convert that to centimetres. So 6 centimetres on the map must match up with 1,200,000 centimetres. Put the unit in there for clarity. Now, to work out the scale on the map as a ratio in its simplest form, we've now got the ratio. It's 6 centimetres on the map to 1,200,000 centimetres in real life, but we need to convert that to its simplest form, so we need to divide by 6. So we've got 1 to 20,000, and that's the answer here. So the answer is 1 to 20,000. Question 8. Jane makes 5-digit numbers using all of these cards. How many different numbers, that's important, greater than 50,000 can she make? So we need to think about the number of options that are available for each card. Now, each card can only be used once, and that makes a difference. And the numbers must be greater than 50,000, which means that in this first box here, we cannot have the 3 or the 4. We can only have the 6, the 7 or the 9 card, which means that there are 3 options for the first box. Now, for the second box, because we've used one of the cards, that means there's only 4 options available for the second box. 3 options, then 2 options, and then 1 option. Okay, every time we use a card, we can no longer reuse the card. So that means we have to work out the value of 3 times 4 times 3 times 2 times 1, and that works out to be 72. You can simplify the calculation by doing this perhaps in pairs. 3 times 4 is 12, and then 3 times 2 times 1 is just 6, so the answer is the answer to 12 times 6, which is 72. Question 9. A spinner was spun 200 times. The relative frequency of landing on a 4 after 50, 100, 150 and 200 spins is shown. Which relative frequency gives the best estimate of the probability? It is the estimate that involved the largest number of trials. So the relative frequency of 0.16, as this was generated from the highest number of spins or trials. Part B. How many times did the spinner land on 4 from spin 51 to spin 500? So we're looking at what happens in this portion of the table. So one thing to remember, the relative frequency is the number of times an event happens. So the number of times we get a 4 divided by the total number of trials, or the total number of spins in this case. So for example, that relative frequency here of 0.4 or 0.14, that has come from the number of 4s that was rolled or spun divided by the number of spins, which was 50. So if we want to work out the number of 4s within those first 50 trials, we need to do 0.14 multiplied by 50. Now, how can we work that calculation out easily? Well, we can do 0.14 multiplied by 100, and then divide that answer by 2. So it's 0.14 multiplied by 50. 0.14 multiplied by 100 is 14, divided by that by 2, it's 7. So the answer to that is 7. So there were 7 4s in between the 0th spin and the 50th spin. Now, if we then focus our attention on this relative frequency of 0.13, that 0.13 has arisen from number of 4s between the 0th and the 100th spin divided by 100. So the number of 4s from spin 0 up to spin 100 is equal to 0.13 multiplied by 100, which is 13. So from spin 0 to 50, the number of 4s is 7. From spin 0 up to spin 100, the number of 4s is 13. So the question's asking us how many 4s are there from spin 51 to spin 100. Well, it's the difference between these. It's 13 take away 7, and the answer is 6. So Tony wants to make 20 small biscuits and 15 large biscuits. Work out how much of each ingredient that he needs. So with the ingredients that he has available, he could make 40 small biscuits or 20 large biscuits based on the quantities that he has. So if he wants to make 20 small biscuits rather than 40 small biscuits, he simply needs to halve these ingredients. So for the small biscuits, he simply needs half of each of these amounts. So he needs 30 grams sugar, 60 grams butter, and 90 grams of flour. Now, for the large biscuits, we have to think more carefully. So this recipe here will make 20 large biscuits, but we want to make 15 large biscuits. So if we think about what we can do, we can divide each of these values by 4, and that will give us the amount of each ingredient for 5 large biscuits. So to work out the amount for 5 large biscuits, so remember, these will make 20 large biscuits. So if we divide them all by 4, that will split up the recipe so that we can work out how much we need for 5 large biscuits. So 60 divided by 4 is 15. So that's 15 grams of sugar. 120 grams of butter divided by 4 is 30 grams of butter. And 180 grams of flour divided by 4, well, divided by 2 is 90, divided by 2 again gives us a division of 4 overall. That's 50 grams of flour. So remember, that's for 5 large biscuits. So we want to know what's going to happen for 15 large biscuits. So remember over here, this was the small biscuits and we wanted 20 of them. So for 15 large biscuits, we now need to take what we've got here and then multiply by 3, multiply each ingredient by 3. So that gives me 45 grams of sugar, 90 grams of butter, and 3 multiplied by 45 is 135 grams of flour. Now, to then work out the total amount needed, I need to add together the ingredients for sugar, butter, and flour separately for the 20 small biscuits and the 15 large biscuits. So 30 grams of sugar plus 45 grams of sugar gives me 75 grams of sugar. 60 grams of butter plus 90 grams of butter gives me 150 grams of butter. 90 grams of flour plus 135 grams of flour gives me 225 grams of flour. That is not the only way of working out the answer to this question. It is just one method. Question 11. Here is a number machine. Write an operation in each box to make the number machine work. So the input is n, and then the output is 3 brackets n take 4. So the first thing that's happened is we subtract 4, and the second thing is we multiply by 3. Part B, work out the value of n when the output and input and output are equal. So here's the input, and it must equal the output. So we set up a very basic, simple equation. N equals 3, brackets n take 4. Expand the brackets on the right hand side. N equals 3n take away 12. This is a very, very simple equation. Subtract n from both sides. So 0 equals 2n minus 12. Add 12. 12 equals 2n, or 2n equals 12. And then divide by 2, so n equals 6. You can write that in on the answer line, n equals 6. Question 12. So 10 different names are put into a computer. One of the names is Jaspal. On Monday, the computer chooses 2 names and the computer is set so the same name can be chosen twice. Find the probability that Jasper is chosen at least once. So this big space here is very, very useful for drawing a tree diagram. So the names can be Jaspal or they can not be Jaspal. So the probability the first name is Jaspal is, of course, 1 in 10. And the probability it's not Jasper, well, there's 9 other names, 9 in 10. Now, because the same name can be picked twice, these probabilities stay the same on the second branch of the tree diagram, which represents the selection of the second name. Now, we're looking for the probability that Jasper is chosen at least once. So that means he could be chosen twice, he could be chosen first and then not chosen, or he might not be chosen as the first name, but then he's chosen as the second name here. So alternatives are to do 1/10 multiplied by 1/10 for this branch here, plus 1/10 multiplied by 9/10 for this branch here, plus 9/10 multiplied by 1/10 for this branch here, or the alternative is to do 1 subtract 9/10 multiplied by 9/10, which is the only branch that we're not using. So if we use the first approach with the 3 calculations here, that will give us 1 over 100 plus 9 over 100 plus 9 over 100, which is of course 19 over 100, the answer here. If we use the second approach, that's 1 take away 81 over 100, which you can think of as 100 over 100 for 1, take away 18 over 100, which is 19 over 100, and that's an alternative approach. Now on Tuesday, the computer chooses 2 names at random and it's set so the same name cannot be chosen twice. Work out the probability that Jasper is chosen now. So the same name cannot be chosen twice. So Jasper is chosen with a probability of 1/10, which means he's not chosen with a probability of 9/10. So that means we're not interested in anything that follows here because it doesn't matter, he can't be chosen again. So if we did draw in the rest of the tree diagram, there's a probability of him being selected 0 afterwards, and the probability of it not being him is 1. So if we follow that path of the tree diagram, we're simply doing 1/10 multiplied by 1, which is, of course, 1/10. Now, if he's not chosen, first of all, he could be chosen in the second time of choosing for name 2, and this time it's a probability of 1 in 9, because of course, having chosen somebody the first time, we're now choosing out of 9 names rather than 10 names, because you cannot choose the same name twice. So that means we need to follow this path here and then this path here. So the calculations are 1/10 multiplied by 1 for this path, plus 9/10 multiplied by 1/9 for the second pair of green branches. So that comes to 1/10 plus 9 over 90. So we need a common denominator here, and we can actually simplify the second fraction. So it's 1/10 plus 1/10, which of course is 2/10 or 1/5 if we simplify the probability down. So question 13, expanding brackets involving surds. Let's start here. So I've got 2 root 5 multiplied by 2 root 5, which is 4 multiplied by 5, which is 20. I'm then going to do 2 root 5 multiplied by root 3, which is going to give me 2 root 15. I then got negative root 3 multiplied by 2 root 5, which gives me negative 2 root 15. And then for the final pairing, I've got root 3, well, negative root 3, it should be, sorry, multiplied by root 3, which gives me negative 3. Now, when we combine these terms, 20 plus 2 root 15 minus 2 root 15 minus 3, you can see that these two terms cancel with each other, so we're left with 20 take away 3, which is 17. But we must show clearly our working, so we're required to show all of this working here. Now, in the equation of this circle over here, we know the equation of a circle is x squared plus y squared equals the radius squared. So 64, the radius squared, tells us the radius must be 8, which means the diameter is double the value of the radius, so it's 16. Question 15, part A, 64 to the power of negative 2/3. So I'm going to split that fractional and negative power in two stages, and I'm going to start by looking at the denominator of the power, 64 to the power of a third, or the cube root of 64, which of course is 4, because 4 cubed is 64. I then want to look at the numerator, so I'm working out 64 to the 2/3, so I take my answer to the previous part, 4, and square it, so that gives me 16. And then 64 to the negative 2/3, well, the negative then takes the reciprocal, so the answer is 1/16. Part B, write this as a power of 3 in terms of x. So 81 is equal to 3 to the power of 4. Now you might be thinking, well, how might I know that? Well, 81, we should know, is 9 squared, which we know 9 is 3 squared, so we're then squaring that again, power of a power, 3 to the power of 4. Now, 27 to the power of 2x, instead of 27, we can write 3 cubed. So it's 3 cubed all to the power of 2x, and then again, power of a power, we multiply the two powers together, so it's 3 to the 6x. So we now have 3 to the 4 multiplied by 3 to the 6x, and we know when we're multiplying, we simplify. When the base is the same, and the base of 3 is the same in both, we add the indices, so it's 3 to the power of 4 plus 6x. Question 16, we have to simplify this, which means we must factorise the numerator and the denominator. So the numerator is going to factorise like this, and then the denominator will factorise like this. We can only take out a 2x plus 3. Just a hint, it's sometimes more helpful to factorise the simpler quadratic first of all, as that will give you a hint as to what the other one will also factorise as, because then cancellation will take place. So if I factorise the denominator first, that would have told me this bracket here, 2x plus 3, is likely to also be in the factorisation of the numerator. So of course, these two will cancel, leaving me with an answer of 2x minus 1 over 2x, and under no circumstances do I try and simplify this further or cross out the 2x's. That is not how the simplification practice works. Question 17, error bounds. So we're going to write down some upper and lower bounds for p and b. P is 68 correct to the nearest whole number, which means p is greater than or equal to 67.5, but less than 68.5. And we know that b, which is correct to one decimal place, must be greater than or equal to 8.65, but less than 8.75. So we've got our correct bounds. Now we want to work out a lower bound for m. So that means we need to make the numerator as small as possible before then dividing by 2. So to make that numerator as small as possible, so we're looking at p minus 2b. If we want to make that as small as possible, that means we want the smaller value for p, which is of course 67.5, and we want to subtract from that as much as possible, so we want to use the larger value of b. So that means that we want to use the smaller value of p first of all, which is 67.5, and from there we want to subtract 2 multiplied by the larger value of b, which is this, 8.75, and then we want to divide the whole thing by 2. So that is 67.5 multiplied by, now 8.75, if I want to double that, let's have a think about that. So if I multiply my 8 by 2, that of course is going to give me 16, and then if I multiply 0.75 by 2, that's 3/4 multiplied by 2. I'm going to multiply that by 2 to get me 1.5. You could also think about 75 times 2 is 150. So 0.75 times 2 is 1.5. So the answer to that is 17.5. So we want to do 67.5, take away 17.5, and then divide by 2. 67.5, take away 17.5, take away 7.5, we go down to 60, take away another 10, we go down to 50, 50 divided by 2, the answer is 25. Question 18, write this quadratic in its completed square format. So we want half of the 10 first of all, so we want x plus 5 all squared. Now when we expand that, we're going to get x squared plus 10x plus 25, so we want to subtract that 25 and then add on the 29 that we are required. So the answer is x plus 5 all squared and then minus a 4 at the end. So part B asks us to think about this problem in reverse, because this is the equation of my quadratic curve. And because that's its turning point, I know that it must have been of the form x plus 2 all squared plus 4. Because we know that the turning point can be read from the completed square form of a quadratic. So for example here, if I'd had y equals x plus 5 all squared minus 4, I would know its turning point, its minimum point, would have an x coordinate of negative 5, because that makes this bracket equal to 0. And then when that bracket is equal to 0, we're left with negative 4. So the coordinates would be minus 5, minus 4. So in reverse, if you look at my quadratic over here, you can see we can read off its x coordinate of its turning point should be minus 2, and its y coordinate should be 4, and that matches the graph. So now all I have to do is expand the brackets. Okay, don't forget this plus 4 here is this plus 4 over the end. And then if I simplify this, x squared plus 4x plus 8, so that tells me that p is the coefficient of x, which is 4, and q is the constant term at the end, which is 8. Question 19. We have some information about students who study geography or history. What does the number 7 on the diagram represent? 7 represents the intersection of geography and history. It represents the students who study both subjects. I'm just going to put geog and hist for short here. So 20 students study geography but not history. So that means there must be 20 in here, geography but not history. 19 students study history overall. So if we've got 7 in the intersection, there must be 12 over here to make 19 in total. If we add 20 plus 7 plus 12, that comes to a total of 39. There are 50 students overall. 50 take away 39 leaves us with 11. There must be 11 students left in this region outside the 2 circles in our Venn diagram who study neither subject. Find the probability that a student chosen at random studies history. There are 19 students in the history section overall, over 50 students in total. Question 20, all about functions. F of 3 is equal to 2 to the power of 3, which is 8. G of minus 1 is equal to minus 1 squared, which is 1. And if we add f of 3 and g of minus 1, we simply get 9. Now, part B is harder. Work out the value of the inverse function f applied to a quarter. Now, working out the inverse function of 2 to the power of x is complex. So what we're saying here is that we start with an input x, we apply f, which means we do 2 to the power of x, whatever x is, and we get an answer of a quarter. And the question's asking us, well, what do we have to do, or what is that starting value? What happens when we apply f to the minus 1 of x to a quarter, when we apply the inverse function? So we're trying to find out what x must have been. So we're saying 2 to the x must equal a quarter. What must x be equal to? Well, how do you choose a power that results in a fraction, in a reciprocal? It's a negative power. And you know, for example, that 2 to the minus 1 is a half. 2 to the minus 2, well, 2 squared is 4. 2 to the minus 2 is a quarter. So the answer is minus 2. If x is equal to minus 2, then that gives you a quarter. Part C, write down an expression for gf of x. Now, we must know the order here. So gf of x means we start with x, we apply f first of all, which means we get 2 to the power x, and we apply g after that, which means we square. So that means we take 2 to the x as our input and we square it. And we've got to give this as a power of 2 in its simplest form. Remember, power of a power means we multiply the powers together. That's 2 to the 2x. Question 21. So we have a non-right angle triangle, and we are told the area of this triangle is 10 root 2 centimetres squared. So we have to work out the value of w. So because we don't know what w is, it doesn't seem sensible to start with the side w. So instead, I'm going to start with these two sides, which are both in terms of x and have an angle of 45 degrees in between them. So we know the area of a triangle is equal to half a times b multiplied by sine of the angle in between them. So that tells me a half multiplied by one of the sides, x, multiplied by another adjacent side there, x plus 3 in brackets, multiplied by the sine of the angle in between them, which is 45, must equal the area of the triangle, which is 10 root 2. So that tells me I've got a half x plus 3. Now sine 45 is root 2 over 2, knowing our exact trig values, equals 10 root 2. I can divide both sides by root 2, which simplifies immediately, and I'm going to multiply both sides by 4 so that I can deal with this factor of a half and this factor of a half in the same moment. So that gives me x bracket x plus 3 equals 40, or x squared plus 3x minus 40 equals 0. Now this is a quadratic which factorises as x plus 8, x minus 5 equals 0. Now the two roots, x equals negative 8, we reject that because x is a length, cannot be negative. The other root, however, x equals 5, is the one that we're going to use. So if I go over to my triangle, I can now use the fact that I have a side of 5 over here. And because we have matching pairs of sides and angles, we can make use of the sine rule. So I can say that w over sine 45 is equal to 5 divided by sine 60. W equals 5 over sine 60 multiplied by sine 45. Now, I'm going to write this as 5 divided by, because otherwise I end up with nested fractions, which are very difficult to deal with. Now, sine of 60 is root 3 over 2, and then we're multiplying by sine 45, which is root 2 over 2. Let's deal with 5 divided by root 3 over 2, fraction division, so that's the same as 5 multiplied by 2 over root 3, and then we're multiplying by this root 2 over 2. 2 in the numerator cancels with 2 in the denominator here, and I've got 5 root 2 over root 3, but the question wants the answer in this format over here, so we need to multiply the numerator and the denominator by root 3, which means we get 5 root 6 in the numerator divided by 3 in the denominator. So a equals 5 and b equals 3. The answer, 5 root 6 over 3. Question 22, a tangent to a circle. We've got to find the coordinates of Q and R, which means we need to find the equation of this tangent first of all. So this is fairly formulaic. First thing we do is find the gradient of OP, which is a radius. So simply going to make sure we use the change in y, 4, divided by the change in x, 3. So that's the gradient of OP. And then the gradient of this tangent here, well, we know that tangent and the radius are perpendicular at the point of contact. So we know that the gradient of the tangent will be the negative reciprocal of 4/3 or minus 3/4. Now the equation of that tangent, we know we can call it y equals mx plus c, and then we'll substitute in the coordinates for p. So that tells me 4 is equal to minus 3/4 multiplied by 3 plus c. So that's 4 equals minus 9 over 4 plus c, which tells me that c is equal to 4 plus 9 over 4. So I can think of that 4 as 16 over 4. So that then tells me my answer is 25 over 4. So my equation of my tangent is y equals minus 3/4 of x plus 25 over 4. Now at point Q, we know that the x coordinate is 0. So if we input x equals 0 into this, then we're going to get y equals 25 over 4. So that tells me that the coordinates of Q are 0, 25 over 4. And the question does ask for coordinates, so I must write 0, 25 over 4. Now, this point over here, R, I've run out of space a little bit on my screen, so I'm going to do this up over here. So at R, we know the y coordinate is 0. So 0 equals minus 3/4 of x plus 25 over 4, subbing y equals 0 into this equation. So if I multiply across by 4, 0 equals minus 3x plus 25, 3x equals 25, x equals 25 over 3. So at point R, the x-coordinate is 25 over 3, the y-coordinate is 0. Question 23, we are looking at the intersection of a curve and a straight line. We've got to show that they have exactly one point of intersection. So this is about simultaneous equations, and we can set both of these equal to each other because they're both equal to y, and this equation that I've just written down will hold at any points of intersection. Simplifying this, 4x squared plus 4x plus 1 equals 0. Now, you could be very clever here and look at the discriminant of this equation, or you can factorise it. It's 2x plus 1, 2x plus 1 equals 0. And this gives us the same root, x equals minus a half. So because we have a repeated root, this tells us there is only one point of intersection. And I must comment on that fact. I can't just stop by getting the values of x, which are repeated values. I must comment on the fact that there's a repeated root, and that means there's only one point of intersection.